Good morning, class. This is a Group 3 software presentation. My name is Luca Orofina.
Ivan Rodriguez.
And I'm Shane O'Neill.
Alright. You remember that time you were invited to that dinner? Maybe it was your girl's parents, you were meeting them for the first time, and you just want to make a good first impression. You go looking for the wine, nice good bottle, you want to look good, and you're looking around the store, you don't know what to get. White wine, red wine, what's good, what's bad? Why is it so expensive? Is it better if it's expensive? I want to get something not so basic. I want to really wow them. How can I show them my great tastes if I don't know anything about wine? Well, we made a program that will categorize your wine as good quality or bad quality using hard facts and statistics.
So we have to make a program with needs. Need has programs. Well, what's the first need? The first need is that the staff's going to be trained on a large data of wines and their attributes. Why? Well, the staff's meant to make a guess about a wine and its qualities. And if you don't train about the data set, it's basically telling them about how certain attributes correlate to certain qualities. So if we don't train it, it's essentially a blind guess. So you don't want a blind guess when telling quality. Okay, for the second user need, the setup will look at a wine classifier and whether or not it's good quality. Telling someone about a wine's quality, you're probably going to be more interested in a wine's quality, an app that can tell you a wine's quality than an app that tell you its citric acid or how much alcohol is in it. And so you can save money if you know the wine's quality without having to buy it. And our third user need, third time's a charm. The staff will take a wine put in by the user and then tell them if their wine's good or bad quality and let the user see wines that are similar to that. So it's basically letting you know, hey, this wine may be worth your money.
Another user need is how the system's going to handle data. The user doesn't have all the inputs on the wine. How can that affect the prediction? Maybe it could crash or cause more bugs, something like that. So we got to find a way to handle all the values. If it's a high number, low number, how we can still give an answer on the quality of the wine. A non-working user need. It's important, it has to give an accurate prediction. We're using a random forest model to be going through all the decision trees, and we have to find an accurate prediction. Right now what we have is 80% accuracy, which is very high, and compared to other databases and other programs doing something similar, 80% is very high for what we're testing for.
So let's just look at a quick demonstration of the software. So here is just a quick run through of our code that would take in the inputted dataset and create a forest. It should be noticed that the forest will be created with 15 trees, each with a maximum depth of 15. And here we have the accuracy, so let's just run this quickly. According to this result, there was a 79% accuracy, and none of the wines tested had predicted to be good quality. So let's try it again. See how many we could get. Here we have true good. It was predicted to be good, and it is good, and not true good. We predicted it to be good, but turns out it's not. And here we have 8%. So now, just do a quick little presenting of reading in the RAM force file. So let's just get rid of all of this. Alright, now before I actually run it, just going to open up the RAM force file that I wrote. Here's just a quick title. Here's number of trees. Starting from the first one, our root node for the first tree, and then we'll do a pre-order transversal. So a branch, The left child is a branch, that left child is a branch, and it'll keep going until it will read through all of these lines and create the corresponding tree. So let's just do a quick test on that. And we see that the result is bad for some randomly taken line, but it managed to read the file and make all the decision trees and correctly assign the random forest its values. Is that it?
Do the classifier. Talk about the search. Okay.
So here's a quick look at the function to search for a similar line. It's mandatory to have the same color.
Yep.
And for any given attribute of the line is within 10% of the inputted line. And then
if it's 10% similar, it's going to increment right here. Add one more similar value. And if similar values are all greater than or equal to 7, it's going to return that value in the data set to show the similar line. And if there's less than that amount of similar values, it will show up as NA.
Which can be seen by returning it to the GUI. Not found, no answer. And found, it writes it. We demonstrated this earlier by running the actual code.
Okay, so here we got one of these databases. We got different parts of it, different attributes that we're going to be using to find the line. The fixed acidity is the amount of tartaric acid, makes it taste acidic. Volatile acidity is acetic acid. It gives it more of a vinegar taste. The wine is an indicator of spoilage. Citric acid is an additive to increase acidity. It can complement a specific flavor. The residual sugar, it comes from the grapes naturally, and it's left over after the fermentation finishes. Chlorides is a way to measure the amount of salt in the wine. Sodium chloride is salt, so chloride is measured to find salt. It can affect the aroma, clearness, and the color of the wine. The difference between free sulfur dioxide and total sulfur dioxide is that the free sulfur aids in preventing microbial growth and the oxidation of the wine. And the total sulfur dioxide is the many different kinds of sulfurs that binds with the components of the wine, such as the pigments. The density of the wine is similar to that of water, and it depends on the percentage of sugar and the amount of alcohol in the wine. The pH is just the acidity of a wine. Most wines range between 3 to 4 on acidity, and lower acidity means it's more prone to oxidation. Something like vinegar, which is very acidic, is more of a 2.5 on the acidity scale, just so you know. And the sulfates, it's the amount of potassium sulfate additive. It's an antioxidant, potassium sulfate. And the alcohol percentage is just the amount of alcohol in the wine. It kind of indicates the body and flavor intensity. And the quality over here, it's between 3 and 8 in the range. So we said that if it's a 7 or above, it's good quality. Anything else is bad quality, because it's very rare for it to be 7 or 8 quality in comparison to all these other values. This is a very large database, and this is just for the red wine. There's another database for white wine. So it gives us a lot of attributes to compare it to in the random tree. In the random variants, over here we're going to do a very brief walkthrough of the code, just to get an idea of how everything works behind the scenes. So first we got the tree node. It's an interface. It's got the branch decision node. It's got the branch or the decision node. Just that. Connects to the branch right over here. Branch node. right here. The branch now got 4 variables, the left to right, the compare attribute and the compare value. The compare attribute, it stores an attribute to compare. It gets the attribute from given and then is compared to the value in the branch to see if it's greater than or less than. And then the compare attribute compares a function right here. The left child and the right child. The left child is less than, the right child is greater than. Right here. This is the right child, less than, greater than. And over here we got the decision node. It starts with to classify the decision. It's specifically meant to be a leaf node. It makes no children, and it only got 2 classifications. Very simple. Good decision or bad decision. It's good or bad quality. Okay. Now here we have the decision tree right here. Using the depth, the attributes, the data set. So we have to start building the tree, calculating the interval, the decision tree travel. It's a very, very important part of the program. We take the depth, the attributes, and the data sets over here. An if statement to set the attributes. We gotta build the tree over here, calculate multiple intervals in between the attributes to find out where we're gonna be splitting in the tree. Little thing over here, we make the minimum so high because we don't want the minimum to be smaller than anything else. And over here in the for loop is where each attribute in the data set goes, and it increases the average by each attribute. And over here we have a little bit of an increment, so we go to the next attribute in the array. Here to be building the tree, we need to set the decision to go to back quality. The Gini index, we have a Gini index, Gini split, split value, and choose split. Those are the 4 values that we have. The Gini index is going to tell us how accurate the split in that is, 1 attribute at a time, and we're going to look for the maximum. And to create the tree, we need to find the current depth, and once the max depth is reached, we have to return the node. It's a recursive function that will increment. Okay. I'll also be making some subsets over here. The left and right childs are the subsets. And to calculate the Gini, we're going to be using an algorithm given to us. We're going to be using an algorithm given to us in the textbook or the slideshow and to find the probability. Right over here. There's a probability of good times 1 minus the probability of good plus the probability of bad times 1 minus the probability of bad. And this is how we're going to determine the gain. Okay. It's going to be the same formula with the left and right. In the decision tree, we've got the reef file. As you can see, it makes the tree, and the way we make it is in a pre-order, which means we're going to start from the root. So we thought it was the easiest way to do this. Start from the root. And if you're wondering, we have a flush right here. The flush is cause everything in the stream to go to a file, which the stream has a max size, and empty the file, which gives you more room to write. Okay, so from there we're going to go to the wine class. The wine Java class is going to have all the get and set attributes. The type, which is the color of the wine, fixed acidity, volatile acidity, everything that we were talking about earlier in the database. obviously. And what we want to do is we want to create a function to take the name and then return a value. Random forest, Java class, got the tree numbers and decision tree. The forest is in an array over here. We get a maximum depth, attributes, number of trees, and we also have a return wine value set, an array that we get from the data set. Okay. We want to have an array of all the attributes from the file, and the amount of wine is in both data sets. We have two data sets, the red and the white. So we have to do this over here for both the red and the white data set. It's for the red, that's for the white. Build the forest, and we're making a test set with 2/3 of the data that's in the original data set. So it's 2/3 the size. And we use a random number generator over here, which we're going to be used to randomly select an attribute in this while loop. And we do that by randomly choosing an index number, so we can have multiple attributes. Each tree has to call a print function, and if there's more good than bad values, then we're going to determine the wine is good. That there's no missing data in this set, and we're going to be setting the quality. Anything greater than 6 is good, and good is going to be number 1, and that will be 0. The wine classifier class is our main class. It's global, which means all the functions have access to it. We have a string of all the attributes right here. As you can see, the color must be first listed. It's very important because it's the two categories are white and red wine in the databases. Okay. The scanner, the red or the white for the dataset file. We have to divide it up. And we call the random forest. We have to set the tree and set the depth. We load the data and return the sheet. And we have to use a scanner random forest to look for the random forest, reading through it and creating it. Calculating the default value, and then also here finding the average for each attribute, which we're going to use for the missing values. Okay. Use the sum, and here we divide it to find the average. Over here we have also a linear search, which we're going to use to find a similar wine. And the way this works is by creating a similar value. It will increment every single time we find an attribute that is similar. So for example, we're going to input a whole list of attributes, and if the inputted attribute is within 10% more or 10% less of a similar number to the attribute in the database, that will increment over here the similar value. And for all the attributes, it's going to happen until eventually it increments to see how it increments the value. If the similar value is equal to or greater than 7 out of all the 11 attributes, then it will be a similar wine. If it has less than 7 similarities, it will not be classified as similar wine. And what will happen is it will output an attribute of the wine that's similar. Okay? And we use the ranges divided by 10 to get 10%. We use a float. Over here we have continue to make sure that the wine color is red or white. It has to be the same as a wine inputted. So you can't have a wine that's similar but a different color. It has to always be the same color. GUI. How we're going to be taking all the inputs right here, and the action listener, and the action perform. Right here we have a catch error if it's not a number. We must enter number. No negative values are also allowed to be entered. And if over here is for the similar wine, if there's no wine within 10% of similarities in 7 attributes, then it will say not available, and there's no similar wine in the data set. Okay. Okay. Here we have the GUI, the GUI. Let's choose the red wine for now. Let's put in some input values and then test it out. So let's just put in some random values. Let's put in see what happens. It's a bad quality wine. Okay, let's see if there's a wine similar to this. There is. And they're both bad quality. Nice. See, maybe same thing for the white. It will make a difference. Bad quality, bad quality. Wow. Okay. Something I could do maybe. Increase that. And maybe I lower the chloride, which is the salt. Okay. Oh, I found a different wine. That's good quality. Look at that. Interesting. Turn the wine back here, and simply, if there's any missing value over here, so we have some missing values. Let's go into. Just going to fill it in. Bad quality. It's going to find another wine. So these missing values are just the averages found in the data set for each of the attribute. So right here it says the average data set for the citric acid out of all the thousands of attributes values in the red wine database. For the white one, it's going to give me a different wine. As you can see, this is a different one from before. And to close the thing, all we have to do is press X, and the program is closed. Alright, major problems encountered. First, we wanted more accurate results in the random forest. Before we were getting in the low 70s accuracy, and we ended up getting it to over 0.8%, 0.8, which is over 80%. How to handle missing values by using the default value. We wanted to know what would happen how we would figure out if there was an empty value, how we would manage that. Will we come up with an error? But we figured out that the best thing is just to get the average of all the values in each attribute that was missing and just automatically put it in if there's no value inputted. When finding similar wines, determine how similar the wine should be. With the linear search, we had to go through the array and look for through the entire data set and we figured out how to compare the inputted value to a value in the data set for each attribute and figure out if it was similar or not, and figure out a way to use it just getting a 10% range, 10% more, 10% less of the value is what we would use to determine if it's similar or not. And then we figured out that it would be similar if it had 6 attributes within that range. Problems with spacing in the GUI.
Well, we had trouble facing, and our biggest problem was switching between these input and output GUIs. That was an issue we had. And we put J panels that had an empty J label for where there was supposed to be an empty space in the GUI. And we used a single J frame that will change between screens when necessary.